Okay, let's unpack this. Anyone who's worked in enterprise software knows the feeling, right? Building reporting systems, data retrieval, processing, transforming it, showing it. It all just gets tangled up, with this code that's, well, frankly, a nightmare to maintain.
It really can be, like
Yeah.
trying to untangle spaghetti code after the fact. But this scientific report you shared, it offers a path through that. It shows an architecture using modern Java, some functional programming ideas, and semantic design. Our mission here is really to pull out those key insights. How do you turn that complex mess into something, well, elegant?
Elegant and maintainable. That's the key. So Java 8 feels like a starting point here. It brought in functional stuff like streams, lambda expressions.
Yeah.
Big shift. How did that really pave the way for, solving this reporting problem?
It's actually quite foundational. Java 8 sort of rediscovered this core idea, functions as first-class citizens. It goes way back, believe it or not, to Alonzo Church's lambda calculus in the 1930s, the blueprint for computation.
Yeah.
So interfaces like java.util.function, function tr, they let us define a transformation. Not just the step-by-step how, but the what. It's a more abstract, powerful way to think about code.
Right, treating logic like building blocks. Makes sense. But in a big, messy enterprise system, how do you keep those blocks separate? How do you enforce that responsibility? Does the report talk about stopping people from just, bending the rules when deadlines loom?
Yes. That's where a custom annotation like @reportPresenter comes into play. It's a stereotype, like springs at service or at component, but more specific. Its only job is to mark classes that transform raw data into, say, a CSV file or a PDF or whatever presentation format you need. So it directly enforces the single responsibility principle, SRP.
SRP. Always easier said than done.
Exactly. But here you have a concrete mechanism. Think database entity load report service. Its job is just getting the raw data done. Then loaded entities SView report service, marked with @reportPresenter, takes that data and only worries about making the CSV string. You get high cohesion classes do one thing well, and low coupling, changing the presentation, doesn't break the data retrieval. That's a huge win.
Okay, so @reportPresenter handles the responsibility. But what about making the code itself clearer, easier to understand just by reading it? Is that where this presentable interface fits in?
Precisely. Presentable is defined as public interface. Presentable TR extends function TR. It's essentially a semantic type alias. It doesn't add new methods, but it adds meaning. So instead of a generic functionless loaded entities report, string, you see presentable list loaded entities report, string.
I see. It tells you the purpose right there in the type name.
Exactly. It screams, I present this data as a string. Much clearer contextually. The report even mentions using a meta annotation at tag interface to formally mark interfaces like presentable that exist mainly for their type meaning. It's like the marker interface pattern Joshua Block talks about in Effective Java. It's about leveraging the type system for clarity.
That makes sense. Clarity is crucial. But what about flexibility? As these systems grow and change, how does this architecture stay robust? How does it adapt?
Yeah, that's a great question. And what's fascinating here is the clever use of wildcards. Specifically, when, say, loaded entities E4SV report service needs the data source, it depends on database entity load report service. It doesn't need to know the exact complex generic types the data source might be using internally. It just needs something that fits the database entity load report service contract.
So it decouples the consumer from the specific implementation details of the provider.
Perfectly put. It enables really loose coupling, like needing a car, any car that drives, not a specific 2023 red Toyota Camry. And interestingly, the report notes that using test-driven development, TDD kind of naturally pushed the design in this direction because TDD forces you to think about clear interfaces and testable units from the start, which often leads to these more robust, decoupled designs.
Right. The testability forces good design habits.
So if we zoom out, connect this to the bigger picture, this whole approach blending modern Java functional features, solid principles like SRP, semantic typing, it really shows a way to build systems that are modular, genuinely maintainable, and surprisingly resilient. It kind of proves Java's still, just great for tackling these complex problems.
So for you listening, what's the takeaway here? Next time you're looking at complex code or maybe building it yourself, ask, are the responsibilities clear? Really clear? Can you use names, even in your types, that make the intent totally obvious? And think about how a little type flexibility, maybe using wildcards strategically, could make your whole system more adaptable and robust down the road. It's worth considering.